Okay, this is a reasonably straightforward problem, and we need to know a couple of things to calculate the frequency of the wave. The first thing we need to know is that velocity, and this is the velocity of light, which is always given the symbol c, is equal to the wavelength times the frequency. In our case, as we want the frequency, we divide both sides by the wavelength to find that c divided by the wavelength is the frequency as required. Okay, c has a numerical value to a very good approximation, 3 times 10 to the 8 meters per second. Now, we have the wavelength, but the wavelength is expressed in nanometers. Wavelength is equal to 632 nanometers. And remember, nano is a prefix which means 10 to the minus 9, so we can immediately rewrite this as 632 times 10 to the minus 9 meters. And putting it together, what we require is the frequency is the velocity of light, 3 times 10 to the 8 meters per second, divided by the wavelength, which is 632 times 10 to the minus 9 meters. So clearly the meters will cancel and we will be left with an answer in per second, and the number that we get is 4.75 times 10 to the 14. So it's a big frequency. It's in units of per second, but the other way of writing the unit per second is hertz. So the frequency is 4.75 times 10 to the 14 hertz. And being nice to the person marking the problem, you will indicate clearly where the answer is to be found. And we're done.